Hello guys, so in this video I'll be talking about services in Kubernetes. First of all, I'll be talking about why do we need services, and then what services are. We'll see a demo code, and then we'll see all type of services that Kubernetes provides, and then we'll look into some other details which comes with services. So let's get started. So why do we need services? So services provides an extra layer, an abstraction over some of the problems or some of the things that are specific to Kubernetes. First is pods are ephemeral. That means the pods, they could be started at any moment, and they could die or be removed at the very next moment, right? So they are not like nodes which needs to be running all the time, or like servers in the conventional way which needs to be running all the time. So we can't trust that the pod would be up. What we can trust is, like, at least there would be some pods of kind X that would be running, right? So we would want to map, or we would want to send the request to that group. We don't know what specific pod it is, but we would know that there would be some pods belonging to specific group that would be serving my request, right? So there, like, we need a layer of abstraction that does the mapping of the request to a group of pods. So that's number one. Like, straight away we can't refer to the pods. There needs to be a abstraction layer, which is what services are. Next is the IPs of the pods. They are not assigned ahead of the time. That means a client can't straight away refer to the pod. So the IPs are only assigned after a pod is scheduled on a node, right? So since the IPs are not assigned, there needs to be a way for the clients to discover the pods, or there needs to be some other mapping that, like, the clients could send requests to some other layer, and that layer forwards all those requests to the pod, right? Whenever it starts, like, that layer could start sending the requests to that pod. Next is we want the horizontal scaling to be simple. That means like, Kubernetes has really good support for updating the number of replicas, or updating the number of pods that are running for a specific task, right? So we want an easy way. That means, like, we could increase the number of pods from 5 to 20 depending upon the incoming traffic. So we want an easy way that all of the requests that are coming, they could be divided from 5 number of pods to number of 20, right? So it could be done in a very easy way. So that's what services provides. So what is a service? So service is a single constant point of entry to a group of pods providing the same service, right? So, like, you have X number of pods that are running here, right? And then you declare an entry point. So all the requests that are coming, these will be hitting that point, right? And this entry layer will be pointing all the requests further to these groups of pods. That's what services are. So let's look at a code which explains these services. So I have a Node app on the left, which I'm highlighting. This is a folder. So the Node app has a Node.js script, which handles the request and serves the response. So this is the main piece of the code that handles the request, where we create a server, and the server runs on this port 3000. So it sees if the requests have the Node app start as the starting URL. So we increment the counter, and then we send the response as hello world. If any other request is coming in, we just reply as 404, and we say that it's unknown path. So that's a simple plain Node.js server. Now we package it. Like, I have a makefile. Basically, I use Docker to build this. So here I build it, and then I push it to the Docker Hub repository. And then we have a Kubernetes definition file where we are using this container. So if you see, this is the same container which we create and which is being used. So I'll deploy it and I'll show it, but let's first look at the metadata and see how services are defined. So again, this is Kubernetes file. So we are trying to declare a deployment here, like an object of type deployment. If you don't know deployment, like you could just focus on that we are running containers, the containers are of type of this image, and we are trying to run like 5 containers, which is like 5 pods of this type of 5 pods, which contains like this container, right? So now we want these pods which are running on port 3000, right? We want them to be serving the incoming requests. So now we don't know what are the IP of these pods, because the IPs are only assigned after they are started, right? So we need a way to point to these. So that's what services are. So here we declare as services, like the API version is v1, the kind is service, and this is metadata, which tells like about the services, what the name and all is. So it's just a name, and then these are the specifications of the service. So here the specification, we say that we are declaring a type of a load balancer service, and then the selector means to which pods do we want to point to, right? So selector always selects the group of the pods to which the request should be sent. So it says the selector is for labels, and we want the labels to be node app. So if I click here, so we could see that it points to this node app, right? So so it points to these pods that would be running. So here we are not referring to which exact pod it would be pointing to, right? We are not mentioning that what are the number of replicas and all within the service. So we just says that which pod should be selected, and that's it. So it does not matter whether one pod is running or whether 10 pods are running. So the service just does it easy for us, and we just declare the selector based on which the pods are selected, and then we declare the port mappings. So this is the port on which the service will be running, right? And then the target port is the port of the container, right, to which we want to send the request. So if you see, the target port is corresponding to the server, like the Node.js server that we have, which is 3000. So node port is the port on the node to which external clients can point to so that they can reach the service, right, which is running here. So this is the internal port, and the node port is the external port. And then session affinity, like we could declare some session affinity configurations and all, whether we want sticky sessions based on the client IP or something else, right? But I could just remove it to make the thing simple. So let's deploy our application and see how the service works. So let's build the application first by using these make commands that we have. So we'll say make docker build, which builds our image. So I've already pushed it, so that's why it was already fast. So sorry, I already built it, that's why it was very fast. And now I would say docker make docker push, which would be pushing this image. So here it is pushing it, right? And so I have Kubernetes already running. So kubectl get all. So I'm running Minikube here, and so if you see here, only the default Kubernetes service is running, nothing else. So I would deploy this application, which has a deployment with 5 replicas, and then it has services, and the name is node app service. So let's say kubectl apply -f Kubernetes in the file name. So it's created a deployment which corresponds to this deployment, and these are the services. So now if we say get all, so these are the pods, and then this is the service. This was the default service that was already running. This is the new service which we created, and this is the name of the deployment. So deployment is the wrapper around pods and all. Yeah, so this is a replica set, which is in turn created by a deployment. So we could see, like, we created a deployment which corresponds to the 5 pods, and we can see the service is running. So let's see the IP of Minikube. So we use this IP, and we'll go to the browser now to try to hit it and see what response do we get. So this is my image which I had pushed. And so let's look at the browser request and see that we get the responses corresponding to it. I will just reload now. And if you see here, this is the response that we had configured. Like, this is how we had configured the node server to respond with hello world and the counter, and then it prints the pod from which the response is coming. So this is the replica set number, but this is the pod ID, right, or the pod number. So if we just reload, now it points to a new pod. That's why the counter incremented from 1. And I reload now, again that's why the counter incremented from 1. So in this case, again, like the same was loaded, that's why the counter is 3. So here, if you see IP, this is the Minikube IP. This is the port which we had declared in our service, right? And this is the URL. So if I just say some other URL, it should say unknown path. Again, let's look at the code to confirm all of these things. So remember, this is the port on which we had configured in the service. So let's look at the code now. So in this code, if you see, this was the external port, this is the internal port 80, and then this is the target port. So externally, whatever requests are coming, they are being forwarded to the containers that are running. So the containers which are selected using this selector and which is running on this port. So the container is basically a node server which is listening to 3000, and it was listening to this URL. If we provide some other URL, it would return the result unknown path. And if the URL matched, in like a lot of requests we saw the URL matching, which was node app. So in that case, it returns the response as hello world and the counter and the name of the host name of the pod. So in this case, now if we need to increment the number of pods and all, it could be done dynamically. That means we don't need to restart anything and all. I just say kubectl apply -f. So it says that the deployment is configured, and if I go to the browser, everything should still be working. So if I go here and I click on node app, so the old pods are still running. This loaded for this. So if you see, like, there would be some pods that would be already having like the counter as 3 or more, right, based on the request that we had sent earlier. So this pod was already running. So that's why you can see how easy it is to horizontally scale the pods. And since the pod never have the IP address and already predefined, so we are not straight away mapping the external port to the port of the pod. That is all done by the service. By the way, if you're liking the video so far, please hit the subscribe button and hit the thumbs up icon, because it motivates me a lot. So Kubernetes comes with 4 types of services, helping us solve different types of needs. Number 1 is cluster IP. That's the default service which Kubernetes provides. So by default, whenever we're using cluster IP, it exposes an IP internally within the cluster itself. It cannot be reached from outside the cluster. Like external clients, they don't know, like they can't access the cluster IP service. So these are used a lot of time in microservices and all. Suppose you have a front-end service that needs to point to the backend service, right? But the backend service, you're not exposing it externally, right? So in those cases, you could just use a cluster IP service. The next is node port. Certain times you want to expose like the service on the node, right? So when you're using a node port service, it exposes the service on each node's IP at a static port. A lot of time we don't use a node port service also, because someone has to know the node IP, right, on which the service is running. Or like if you're using load balancer, your own load balancer in front of your node IPs, you could use it, right? So, or there is another type of service which is load balancer, which does the same thing for you. Means it uses the cloud provider's load balancer. So Kubernetes does not come with any default cloud load balancer. Wherever you are running load balancer, like wherever you're running Kubernetes, if you are using the service of type load balancer, it would use the cloud provider's load balancer and would point it to those to all the nodes. So in our case, when I was running on my local, since I was using Minikube does not have any load balancer service. So by default, load balancer is the exact same as node port, right? And it was exposing the service on the node's IP, right, on the static port. That is what we did. And then is the external name. Certain times you don't want to just point to the pods. Maybe you want to create a mapping, right, and you want to refer to some external clients. So the domain name or IP addresses in all of the external clients could change. So then you want to just create a mapping, right? So you could use an external name mapping for it and then point to some external domain names or external IPs. So we'll look at all these types of services in the code. So here I have all those types of services. We'll just minimize this. We'll look one service at a time. So the first one is the cluster IP. As I said, like you use the type as cluster IP. Even if you remove it, right, this one, so it would by default take it as the cluster IP. That's the default type. And then selector, you mention like what type of like which pods do you want to select, and you give the target port. Node port does not make any sense in this case, so it should be removed. Again, this is used within the cluster itself, right? And these services are not exposed externally. Let's look at the next service type, which is node port. So in node port, you tell like what is the external node port you want to use, and then this service will expose nodes externally on each of the nodes port, right? Each of the nodes port. In Minikube, as I said, like this is exactly same as load balancer. There's nothing special there. So we were just giving the exact same configurations for load balancer services. So if you see here, this was the load balancer. This was the exact same configuration, only the type was different. But if you are actually running on a cloud provider's environment like AWS or Google, in those cases, actual load balancer of AWS or Google would be used. And then is the last kind, which is of the type external name. When you're using an external name, it would just expose a service, right, and it points to this external name. So these are the 4 types of services that we have in Kubernetes. So as we saw that we could expose the services internally or externally. Like suppose when we are exposing them internally, like an IP is assigned to the services, but the pods are not aware of that IP straight away, because like they all know that there is a service that's running, right, and they want to discover that service so that they can start sending the request to that service. So there are 2 ways like using which pods could discover the services. Number 1 is using environment variables. So what Kubernetes does, it assigns a few environment variables, specifically 2, which refers to the service name _service_host, which points to the IP address on which the service is running, and the next one is service name _service_port, which refers to the port on which the service is running. So let's log into one of the nodes and try to see these environment variables. My IDE provides an easy way to log on to any of these pods, right? So I just log on to one of these pods. I would say run shell, but you could just use kubectl exec command to do the same. So I would say env, which prints the environment, and my node's name, my service name was like, it prints all the environment variables. So I would just filter out the relevant ones, and I will say grep -i, and the service name was node app, right? So if you see like this one port, it refers to node app. So if you see node app service port, it points to the exact port on which service is running, and this node app service _service_host, this points to the IP address on which service is running, right? So this is the IP address and this is the port. So it sets some other environment variables also, which you could ignore. But using those two environment variables, you could just you could get to know on which IP and which port your service is running, and then you could just send all of the traffic to this IP address in this port. So there is other way using which you could point to the services, and the other way is using DNS. So you could just point to, you could send all the traffic to, like, you could just send it to host name, like my service, my hyphen service hyphen name. This is the name of the service, and you could just use this name if your service is running in the default namespace. But if your service is running in specific namespace, you have to use a fully qualified name, which is like the service name dot the namespace name, right? If your service is running in something like my namespace, right? My namespace is the name of the other namespace in which your service is running. So so this DNS mappings is also configured by Kubernetes inside your pod. So whenever your pod starts, it is aware of the internal DNS which is running in Kubernetes. So whenever you are using this, like my hyphen service hyphen name as the domain name, right? Just like you could be pointing to api.google.com or something like api.facebook.com, like to reach there to external services. Similarly, you could just use my hyphen service hyphen name. This is the name to point to your own service which is running within Kubernetes. And if it is running in a specific namespace, you use the name of the service dot my namespace, like which is the namespace name, and then refer to the service. So in the next video, I will be talking about how services work internally. So if you like the full video, please subscribe to my channel and hit the like button, because it motivates me a lot to make more such videos.